Okay. Now, in continuous to my previous class, I just would like to take up one more this substrate. Okay. So you just see here, you have two functional group. What are they? They are nothing but a keto group. One is a ketone. Okay. The other one is the olefin. Okay. I just want to synthesize this kind of. I want to make use of this kind of starting material to synthesize different kind of derivatives. So, for example, I want to synthesize this target molecule 1 and target molecule 2. Okay, so this target molecule 1 and 2 can be synthesized from this kind of what it calls a alpha beta unsaturated carbonyl group, carbonyl compounds. Okay, so now you have a analysis of this, the polarity. Now you take your keto group, okay, and then you try to understand about the polarity. Now, as you know, this is going to have a delta negative and this is going to have a delta plus 1. So when I'm going to have a carbonyl group, a carbon as a delta plus, obviously this is going to be delta negative and this is going to be delta plus 1 here. Okay, fine. So now if I want to do anything, to add to this particular one, okay, I can have a nucleophile can be added to this. A nucleophile can be added to which carbon? This is alpha carbon and this is my beta carbon. So what I can add? I can add a electrophile to this. A nucleophile can be added here. So in this kind of cases where if I'm going to have what you can call to synthesize this kind of molecule. Okay, what is this? This is nothing but a keto group having a alkyl CH2 group. Now I want to synthesize this. So how I can do that? It's a very simple method. You just take this kind of what you can call alpha beta unsaturated one and try to add a species having a negative charge. Okay, your species is going to have a negative charge. So how a methyl group can be have a negative charge in one? As we already discussed, one can go for a Grignard reagent, okay, or you can go for Grignard reagent, or you can also go for what you can call organometallic compounds. Okay, so you take organometallic compounds and try to that particular organometallic compound can give rise to a nucleophilic carbons. Okay, so you take this kind of what you can call unsaturated system and try to take say for example, if you take this kind of one, okay, dimethyl copper lithium, okay, where the copper is going to have a positive charge because it's a more electronegative atom and methyl group is going to have a negative charge here. So you just take this and then the second condition is that you just try to hydrolyze it, okay, with the acid, so you can get the what you can call methyl group, which is a negative charge, which is going to add to the particular substrate. So where it's going to add? It's going to add, as we already discussed, it's going to add at the beta carbon, because beta carbon is a electrophile. What is the alpha carbon? Is a nucleophile. So alpha carbon is a nucleophile and beta carbon is a electrophile. Now if you see, the reaction is a very simple one, where it is going to first form a what you can call a complex. Okay, a complex gets formed between dimethyl lithium. So we have a lithium plus ions here and positive charge here. So this is going to make a what you can call a complex here. So it is going to form a pi complex. I'm not going to discuss about that intermediate. Rather, I just want to tell you that this methyl group, which is present on the copper, gets migrated and is going to attack the beta carbon. So this is your alpha carbon and this is beta carbon. So what is the charge on this methyl group? Is going to be a negative charge. So it's going to add and it's going to form a shift to the double bond. It gets, so you will be getting what you can call this kind of intermediate. And upon hydrolysis, you will be getting, so you will be having a formation of a negative charge species here negative charge, and you have a carbon-carbon bond formation, and this is your beta carbon, okay, and this is your alpha carbon, this is your beta carbon, and your nucleophile. What is the nucleophile here? A CH3 group. Okay, then nucleophiles gets added, and this becomes negative charge. Okay, so now if you see, the next step is very simple, where it gets a negative charge, okay, and it is going to form a CH minus CH2 CH3, which takes up a proton from the solvent, okay, to form a neutral molecule. That is nothing but your CH2 CH2 CH3. Now if you try to analyze this molecule, okay, where you added two substrates. What are they? One is the hydrogen, another one is methyl group. Okay, so if you want, you can do this analysis, retrosynthesis, where I'm adding a hydrogen and methyl group to my alpha beta unsaturated system. Okay, I don't need to discuss more about this, because you might have studied in the case of what you can call 1,4 addition. This comes under what you can call 1,4 addition product, 1,4 addition. So this is also called as a conjugate addition. Okay, so now you need to have a negative charged methyl group and positive charged species. So if you can have these two, one can able to get this kind of what you can call a long alkane carbonyl group here. Okay, now again you just take the second example. So second example, where I'm having a Me twice, Me twice, that is a dimethylamine group, okay, and then one is a hydrogen. So now you try to do the retro part. What is the retro part? You try to disconnect it. So if you can able to disconnect it, you will be getting, so you remove hydrogen from this, remove Me twice from this, so you will be getting ended up with what you can call a negative charge, okay, a positive charge on this, a negative charge on this. Okay, so now you try to connect them, so obviously you will be getting the corresponding synthon is going to be 1 CH2 group. There is a CH2 group. Okay, so what is this? This is nothing but my alpha beta unsaturated carbonyl compound. Okay, so in the alpha beta unsaturated carbonyl group, I can add, so this is going to be negative charge, a positive charge, negative charge, positive. So I can add a nucleophile at the beta position, I can add electrophile at the alpha position. Okay, so by making use of what you can call as a simple polarity, okay, of this carbonyl group, I can keep on extending it. Okay, so this is the case where, now what is the starting material for this? What is the synthesis? You take an alpha beta unsaturated compound, you treat this with dimethylamine. If you treat this with dimethylamine, one can able to synthesize this compound. It's very simple. You take alpha beta unsaturated carbonyl group compound, you treat this with the NMe twice, NMe twice, okay, a simple conjugated addition takes place to give rise to the product. Okay, Me twice, and hydrogen gets added to here. Over. Okay, so you have two hydrogens over here. So whenever you get this kind of what you can call a monofunctional carbonyl group having an unsaturated system, one can always go for what you can call a polarity aspects. So you just go for the polarity aspects, where whether alpha is going to be negative, positive, etc. Now one can also generalize this. So how to generalize it? You just take any kind of carbonyl compound, take a carbonyl compound, okay, take a carbonyl compound, and then you extend this. You can extend this to any number of, provided you must have the unsaturated system. Okay, so as I told you already, this is going to have the carbonyl oxygen is going to have a negative charge, this is going to have a positive charge, negative charge, positive charge, negative, positive, negative, positive. negative, positive. Okay, so this nucleophile, okay, so you can add an electrophile to this. Okay, this is going to be electrophile. Okay, you can add a nucleophile to this. Like this, I can keep on extending. So this is nothing but your alpha carbon, beta, gamma, delta, omega, like this. Okay, it's keep moving. Okay, from one to the other substrate. Okay, fine. So is it clear? So polarity aspect is very, very important to understand about this kind of carbonyl compounds. Okay.